Okay. See, indexes will help us to improve the data retrieval process. Now, we have this table. So let me see. Okay, so for now I have my table. So my table is having like 15 records. To fetch 15 records from my table, it is taking 0.002 milliseconds. Okay, right? To fetch a whole records from the table, it is taking 0.02 milliseconds. Now I'm going to like where employee number equals to 7698. 7698. To fetch this record also, it is taking 0.003 milliseconds. Can you observe here? It is taking 0.0002 milliseconds to fetch 14 records. Sorry, 15 records. To fetch one record, also it is taking 0.02 milliseconds. Right? See, you cannot go with timing actually. So you can go with the cardinality and cost of that particular query. Right? You can go with like this. See, simply right click that query, right click on that particular query, go for the explain plan and see the explain plan like this. Or you can press simply F10. This will give the plan of that particular query. Okay. Now, to fetch like a 14 records, cardinality, how many distinct records you are displaying that particular query, that you are going to get in this place. How many distinct records you are going to display, that we can say cardinality. And cost to run this, to display these 14 records from the system. So you are using some CPU utilization, right? So you are utilizing like 3 bytes of memory, 3 bytes of memory in CPU. Okay. Now to fetch like 14 records, it is taking this much time. And one for one record also it is taking like the same time. Okay. So how can we improve? How can we improve that performance? See, the meaning of this, what it is doing, the Oracle is searching the data while displaying that on the screen. Just one second. We have the Oracle book. If you take like Oracle textbook, okay. See, the Oracle page does not know like what are the topics on which page it is available. If you don't have idea on that, so if you are looking for the index concept now, or if you are looking for the constraints concept, okay, you may get the constraint concept in the middle of the pages. Okay, so you are trying to retrieve the page one by one page, and you are searching the required topic is in which place, on which page. Okay, so if you found that also, you need to be search the remaining pages as well, because the indexes or constraint topic may be available in the other place as well. Or you can take the example for the searching of the people, like you are trying to find the people like who in some village, you don't have the exactly, see, we have just name of the person, so you don't have exact address of that him. So like Shiva from AP, right? See, if you know this much only, you need to found all the Shivas from the entire AP. You cannot able to go and search only the Shivas from entire AP. You need to search each and every person of the AP. Then only you can get all the Shivas from like a AP, right? So you cannot able to identify this is the Shiva, this is the Shiva. You cannot able to identify. So you need to search. You need to inquire each and every person and need to note it down of each and every Shiva in some place, and you can filter out which Shiva you are looking for. Okay. See, the meaning of this, if you found, so if you want to count like all the heads also, it is taking the same time. If you want to count only the Shivas from that particular AP, it is taking the same time, because you are looking for all the persons in you are inquiring with each and every person of the village or the state, right? So if you are again you are filtering the data from that the whole results, correct? See, the timing will be won't change if you don't have the index page. See, the index page will sort the topic wise and keep the data in a particular page, right? So if you have the names, okay. See, in case if you want to search the population information in the population table or the village, okay. See, the backend, the Oracle will maintain the index ID for that. Index ID, if you create some index ID for this column, let's create. See, I said like we have two types of tables. So just like whatever the table we are using, it's a heap table. And I said another table, it's a IoT table, index organized table. So if we insert like one, so 4, 5, 2, 6. The data will be keep the same way in this. Okay. So now if you create the IoT table, index organized table. So the meaning of this, now you created one, you created 4, 5, 2. Same data I'm saying, I'm inserting here as well. Okay. See, the data will be persist same if first in first. The heap table logic is first in first. If you are the bigger, if you are the smaller than me, or if you are bigger than me, so it won't care about that all rules and regulations. So who came first? I'm giving the opportunity for them. Here in this case, so if you are getting like a lower person, I mean a smaller value, I will keep this data in this. And 4, I inserted here. Now I got 5. That is also fine. Now I got the 2. See, my data is getting sorted in this place still. Okay. So let's insert in this way, then you can understand. Then 1, 2. Now if you remove this, okay. So if you insert like 1, 4, 5, right? Till now this fine. Now you are going to insert fourth element, 1, 4, 5, 2, right? If you insert this data, the data is going to sort. The data is going to sort in this way. 1, 2, 4, 5. See, if you insert the values in this way, the data is going to sort in this format. If you insert like 3 now, again, the data is going to sort again. See, now the data is going to sort in this way. So the meaning of this, if you are if you are trying to save the employee information, if you are trying to search the employee, like customer information in some of the table, if you want to filter all the starting with Shiva or starting with A letters, right? So in this case, all the A names will be sorted in the first. All Z names will go to the last. If you are filtering the data from this table, now you are trying to find like a Shiva. So you can ignore from till A to S, A to R. Then you can find like a S values, all the S values in some place, right? Now you are trying to find like a 3 value in this particular results. So you no need to search from the starting, or you are searching from the starting. So you are looking for the third value. So you won't get like other than like from next row, you won't see these values, right? See what I am going to see. A, B, C. See, the data is in the all the A is in one place, all the B is in one place. Okay. To insert anything like this, the data will be sorted in a respective order. The data gets sorted. So you can sort the data. Maybe you have some options in this. Okay. If you insert the data in this format, the data is going to sort in this format. Now you are looking for the A names, starting with A names. All the A names will started and ended with this place. You won't see any name other than this from next to this row. Next to this row, right? See, this we have. Now I'm going to fetch the data from the table. So where employee number equals to 1, 2, 3, 4. Now I'm fetching this. Still it is taking now extra time, 0.0 milliseconds. Right? Now I am trying to fetch the explain plan for this. See, to fetch 14 records, it is taking only 2 bytes. To fetch all the data, it is taking only 2 bytes. You can check. No, 14 records, it is taking 3 bytes. And for fetching one record also, it is taking 3 bytes. Right? See, if you create the index for this particular column, simply create index ind underscore. The name should be valid. So now I'm going to make the index for the employee number on EMP table. So just I mention IND EMP number on table name of column name, employee number. Now index got created. Now index got created. You can check now. You can check now how the cardinalities change. See, now you are fetching the only one record, but it is taking only 2 bytes of memory. It is taking only 2 bytes of memory. See, you cannot able to guess the performance or the cardinality and all those things where we have like a minimum 1000 rows above. Then only you can able to get the results somewhat different. Okay, still you are saying 1 byte of saving here. Okay, now see, it is showing the table access EMP. You are accessing the table EMP by index by row ID. Index by row ID. It is going for the range scan. It is not going for the full scan. You can check now. Now it will go for the full scan. Table access. The option it is going for full. Now if we go with like this, it is going for the range scan. Okay. So here we have some scanning mechanisms. So if you are using the indexer column in the where class, if you are using the indexer column in the where class, if you are seeing the index page on the textbook, that will help you to reach your destination fastly. So now your topic will be in the 10th page. So you cannot able to go 1, 2, 3, 4 like this. You may pick some of the quantity papers like 4, 5 papers or 6, 7 or 10 paper directly. So you can go in that way in the same format in the backend. Oracle will sort the data as the format of IoT as this format. So it just work as a IoT table, index organizer table, and it will filter the data from that particular table. Okay. Now the indexes without knowing you already created some indexes for the sum of the columns. Okay. So by creating of constraints, it automatically creates some indexes on the table. User underscore Okay, so user underscore constraints. See, here we have like a primary key and unique key and check constraint. Okay, so go and set the values. See all the column values you can observe here. See, for primary key and unique key, last two highlighted ones is one is the primary key, one is the unique key. So and above three is index owner, index name, it is showing null for the check constraint or not null constraint. Right? If you create the primary key of any column or unique key of any column, Oracle will create the index for that. Oracle will create automatically unique index for this, just like as a Aadhaar number. See, if we have like multiple like persons XYZ or any ABC person, if we have, see the same name, if we have the same name, you cannot say like both are the same persons. Both will be different persons. Okay, even if it is twins, the even twins also having the same name and data born and everything, data birth and everything will be same, father and mother and everything same, but they have these two-person having the different other numbers. The same way, if you have the if you want to maintain any unique of values in that particular column of the particular table, so in such case you can able to create the indexes constraint for that. If you create the constraint primary key or unique key, it automatically create unique index for that. Unique index will help us to restrict the duplicates. Okay, now I created this. It's a normal index. Okay, if you are creating the table by default, it is taking how it is creating the default like heap table. The same way, if you are creating the table, sorry, index, by default it will create the B tree. B tree index it get create. See, B tree index it get create. See, for which index, sorry, which column you can create the B tree. For which column you can create another indexes. Okay. See, where we have like multiple values. So if you are seeing this value, okay. So where we are seeing like, if we have gender column in this, to add the column, alter table emp add. Yeah. Okay, now I added the column for this table, emp table. Now let emp set s6 equals to okay, so repeat number equals to okay. Now I created the table and we have these tables. Okay. Now if you see these columns for employee number, so how many distinct values we have? More than one or more than two, sorry. If you have more than two of values of any column, that we can say high cardinality. If we are showing like more number of distinct values in the entire table, if we are showing, if we are seeing more than like else we can say more than two. Okay, if we are seeing more than two distinct values for the entire table, that we can say it's a high cardinality column. If we are seeing like for the six column is having the entire of the you are seeing only two distinct values for the entire column or entire records. This we can call it as a low cardinality column. See, low cardinality in the sense how many distinct values we have in that particular column, that we can call it as a cardinality. If it is having high, it is a more than two, such kind, we can say high cardinality. If it is a less in the sense, one or two only, that we can say less cardinality. So if you have only one value, so no use to maintain the index for that particular column. All are same, right? If you want to, why should you need to filter that based on that particular column, right? If you have like male and female, so now you want to filter like only the male employees or female employees. In such case, you can simply go with the where sex equal to F or M, right? So it help you. So if you have only single value, no need to create the index for that. It is if you are creating the index on that, meaning it's a waste of memory if you are killing the time and memory. Okay. Now we created the index on the for what? We created the B tree index. Okay. We created the B tree index. See why I'm saying the B tree, right? See, the index can work in this way. Okay, the index is going to work in this way. Tagore, if you observe the Tagore movie, so how like so he's saying like I'm doing the help you, so you no need to give anything for me. So you can help with someone like who have in trouble. So I'm giving the trouble. You are helping for one person. You are asking the him to support with two persons, right? In the same way, the data is going to split every person into two parts. Okay, I will help you now. See some other things for this. If we create the index for this particular thing, the data is going to sort all the ones in come to the first. Okay. So how many values we have? 3, 6. Sorry, 3, 6. No. 6 plus 4. 10 values we have. Okay. If we have the 10 values, the data is going to split all the ones in one place, 2 in one place, then the 4, then the, sorry, 3. Okay. Now then the 4, right? Sometimes the 4 also will come to this place. Okay. All 4s will be coming in this place. Then it go to the, what other values we have? 4, 4. It's gone. Then we have, so 6, 8, 9. Okay. 6, 8, 9. Okay. Now you are trying to filter the data on the second element or 8 of this particular values. Okay. Each and every element we have in the different row. How we have like this 1, 2, 3, 4, 7, 3, 6, 9, 7, 4, 9. How we have the distant values. The same way we are going to store the values. All the values will be sorted 1, 1, 2, 3 like this. Okay, I haven't sorted in this place. The data is going to sort for this and I'm going to split the data in this format. See, this is the one node. The node is becoming like again two subnodes. Okay, each and every subnode is becoming like again the value like now you are finding like employee number equal to like 6 or 8. Okay, the data is going to split into two parts and such that like 6 is present in this particular first node or second node. If the value is present in the first node, okay, the value is present in the first node, it continue the search operation. Again, this node is becoming like I say two nodes. It's separate in that 1, 1, 2, 2, 2. Then it will go for 3, 4, 4. Then if you come to this place, And let's split this 6, 8. And it come to the 9. Okay. See, now the data is splitted in this format. See, now you are trying to search the sixth value. See, it split that into two parts. Main node is become again, it is bifurcated into two nodes. And you are searching that 8 is present in this first set. No. The search operation is going to stop for this entire record from this particular place itself. It ignoring this all the records. And it is going to search this operation from this particular records only, not with the half of the record. The half of the record has been ignored in the first step itself, and it is going to search the value 6, 8, 9. Now we have the 6 in the first set. So in this second set, we don't have the 9. The search operation now is again splitted into in this format 6. We have 8. Now you are trying to find the 6. The value is present in the first set. So again, it try to search in the second set as well. Maybe if you have the two values, it can be splitted into two values until. Okay, if you have the 6 in this place as well, it will display all the 6 for you. Okay, if it is the unique index, you cannot see any duplicate values in this format. So you cannot see like 1, 1. You can able to see 1, 2, 3, 4, something like this. Because the unique index or unique constraint is going to restrict the duplicates, right? Each and every person, it creates some unique ID for them. Okay. Now you created this. See, that's the reason. See, I'm not designing that as a tree manner. So how the tree will become? So the tree is having each and every leaves, right? It working as a leaf format, tree and leaf kind. So that's the reason these people will call it as a B tree index. This, right? The index concept is understand for the. I mean, the B tree index got any doubt or clear? It's splitting the data, right? Yes. Yes. It's splitting the data is not you need to understand one. So see the understanding is here. The indexes will improve the performance of the query data retrieval process. Okay. Okay. It is improving the select statement performance. How it is working in the backend? So the data is going to split whole values into two parts. Again, the two parts will becoming another two parts. Each and every part will split it into two parts until unless you are get your what the value you are looking for. Okay. Okay. So that's the reason it is splitting that tree into multiple leaves. That's the reason we can call it as this is the B tree index. Okay. So now we created the index. Okay. Now we have another index as well. So now you learn the default index or B tree index. By default, if you are creating the index, the system can understand the user got created as a B tree index. Okay. And we have like a bitmap index. See, we don't have option to create the bitmap index. So if you want to create the bitmap index, the cardinality should be less for that particular column. A low cardinality columns will create the bitmap index. Okay. So how will you create the bitmap index? Simple. So how you created the index? The same way, you can add some extra keyword bitmap. Okay. So go with less cardinality columns. Okay. So this we can able to create in this way, bitmap index. Okay. So you can search like you can try with this. So after creating the index, so how to see the cardinality and cost of that things. Okay. You are fetching like a 14 records, but it is taking only Sorry, this is not like correct. Should not correct. Let me drop that index and try to fetch that. Okay. I'm going to, for high cardinality columns, you can create this normal index, right? Now I'm trying to fetch the values, dropping this index. While creating the index, you need to specify the index type also, but while dropping that, you don't need to mention this. Okay. Now, what we have? X equals to M. Okay. So for fetching 3 records, it is taking 5 seconds. Now see, the cardinality, it is saying 1. Cardinality, it is showing as a 1, right? So I said, how many distinct values we have in this particular columns, how many records we are filtering in this entire column, that it will display, okay, as a M. If you mention like a sex in M comma F, then you may see cardinality as a 2. It is not, it is not. It is not displaying like that. Okay. So now the cardinality in the sense how many distinct values we have in this particular column. Okay. Keep in mind that. Okay. Then, so then you can see this. Okay. How many bytes it is taking? 3 bytes, right? If I create the index on this particular thing, okay, then you can again search this. See, it is going for by index row ID, 2 row IDs. Okay, single value. See, now the cost has been reduced, right? Now I'm creating the same index as a normal index. Instead of going with bitmap index, I'm creating with normal index. Okay, can you try to filter the data from now? I mean, such that is also taking 1 byte only. Okay, if you are seeing like lakhs of data, right? In such case, definitely it will the cost will be high. The cost it will show as a high, where we have like a, if you are using like a low cardinality column, if you are using like normal index, it will give the cost is very high for that. Okay. Now try to insert like some sample data in some like example tables and try to search for that. Then you can get to know the things very clearly. Okay, so we created the B-tree index and bitmap index. Okay, so is there any other indexes to create in the Oracle? So we have other indexes. See, the client is passing the values in the F, right? You are not getting the value. Okay, so the client is going to display, going to like pass the input as in the lower case, not in an uppercase. But your values will be present in your table as in the uppercase. How can you convert that to the uppercase without disturbing the input? So the user may give the results as in capital letter or small letter or init cap, any format like he try to give, but I don't want to disturb their flexibility to give the values to the system. So I'm keeping that So whatever the format he is going to present in the screen, that I'm going to take, and I'm going to convert these values to the whatever the format is required for me. I'm going to convert with that. I'm giving the flexibility to provide the any format of value in the front end. Okay. Now see, now it is showing the values, right? See here, the sex value is having in the uppercase. So the user value, the input value, I'm going to represent in the converting that to the uppercase. Okay. Now you can check this. The column is having index, right? Now you can search for that index is using or not. Still, it is using an index. Index is using. If you are anyone is using like a 11G this kind, right? You can observe in that, or you can go with ename. Okay, substr of. So I'm going to search like so whose first name is equal to S. I mean first letter of the employee name equal to S. Who is having that I need to retrieve. Okay, so ename 1, 1 equals to S. Okay, now I'm going to get the values, but I'm creating the index as well for this F10. To fetch one record, it is taking like 3 bytes. Now I'm creating the normal index. Now I'm creating the normal index for any. Try to see. My table is having index, right? But it is going for the full scan. You can check now. I created the index on this. To create the indexes is going to store in user underscore indexes. Where table underscore name equals to emp. See, my table is having two indexes. Okay, IND EMP number, IND sex. So this column, see, if you create a constraint, the constraint is going to store in a user underscore constraints. If you want to know the constraint is created for which column of that particular table. So where you can get user underscore cons underscore columns. The same way we have another meta object or a data dictionary table, user underscore IND underscore calls. Columns. See, now the say IND underscore SEX column, that index name is created for employee name. See, I haven't changed the name of that particular index name. Okay, but I created the index on this. Okay, on employee name. Okay, see now see, you can observe here descending or ascending. It is see the data is sorted in ascending order. Okay, so if you create the index, the data is going to sort and store that information in the ascending order. Okay, so let's see. If you create the index, if you are using that in index in the where class, that need to be save your time. That need to be improve the performance of your statement. See, you are fetching only one record, but you are trying to use the 3 bytes of memory. So the table scanning, it is going for the full scan, not with the range scan, right? Because if you create the index, that need to the scanning need to be used in the what we just say range scan, not in the full scan. Okay. Now, how can we so make it this system to clear? So the index need to be used here. right? So if you are using that with the help of, you are not using this direct column of index column. So how you create the index on that particular, see, if you created the index for the employee name column directly, you haven't used any functions for that particular column. Just you created the index for that particular employee name column. If we use like, if we use like where ename equals to Smith. Okay, you can check now. See, it is going for the range scan now, right? If you are using directly how you created the index in this direct column, if you are using the index is working here, right? If you are adding some function for that indexed column, the index uses won't be happen. The index won't work. The index, the system cannot understand. Maybe the column does not have index because the Oracle does not understand this. If you're adding some function for that indexed column, right? Now it is going for the full scan. How can you make this improve? So how can you improve this? How whatever the function, what the function with the help of which function you are creating with function, which function you are using in the where class, use the same function in the creation of index itself. See, instead of going with directly, go with EMP of substr of ename 1 comma 1. Okay, 1 comma 1. So now I'm dropping this and I'm using the same index now, right? So now search, try to filter this data and you see the cardinality of this. See, now it is going, now it is using that range scan, not the full scan. Clear? I'm going to recover this topic by tomorrow again. So because I'm on offline, sorry, I'm in online, right? So I cannot able to give like much idea. So I'm going to recap by things tomorrow again. No worries. Okay. So this we can call it as a function based index. If we are creating the index with the help of any function, that may be any function, not only the substring function, you can use upper length, anything. If we are using any, if you are creating any index with the help of some function, okay, that we can call it as a function based index. This we can call it as a function based index. Okay, so we learn like three types of indexes: B-tree index, bitmap, function based index. And you already know about unique index. See, unique index, I'm going to insert some value into my EMP table. Okay, let's create for the index. So, okay, so my employee table I have. So, is there any duplicate employee number? You can search for this first. You don't have any duplicate numbers. So, how can you identify your table is having the duplicate or not on that particular column? How can you identify? What man? The listening class is not important here. So it's a mathematical subject, how the difficulty we have. The same way, this is also. So how
Union
can
function,
you count
distinct.
function we have? Count of employee number. It counts all the records of your table. You want to count the values in the column. So count of employee number, right? It is giving count star and count of employee number both is the same. If I use count of commission, So now you may see some difference here. 4. Why it is getting that 14, sorry, 15 and 4. See, the thing is, the count function is going to count the number of rows if we use a star. Count star, in the sense, the whole record as a treat like as a one. All the column of information, a treat as a one row. Even for all the rows, it is having the null also, it will count this. Okay. Now, if you come to the while using the individual column of that in the count function, it it counts the not null values for the entire records in this particular column. This. Okay. Then we have commission column. So commission column is having how many distinct values we have. So how many not null values we have? 4. This is what you are getting. You want to know the distinct values in this. Okay, go with so count of sal as well. Whether it is really working or not, that also you need to check, right? So because each and every employee, I inserted the salary, but there is some duplicates. 1250 is having the duplicate, 3000 also having the duplicate. So we have 2 duplicate values, right? If I use the count of sal, it is saying the 15 we have. If I use the count of distinct sal, I'm removing these all things.
By using group by, you can find, we can
That
find
also,
out
that
the.
also, that also works. That also works. Okay. Count of distinct sal. Just I need to, I don't want to display what the having the duplicates. Just I need to know how many duplicates we have. Right? See, now we have the duplicates in this. The salary column is having the duplicates. Okay. Now I'm trying to create the index. Unique index. Now I'm dropping this. What we have index. This X index I drop. And I'm employee number index also I drop. So instead of bitmap, I'm using unique index. Just simply use the unique keyword. Create unique index for which column you are creating EMP number UK. Mention like a unique index. Okay, so employee number. Now it is creating that index. It is not giving any error for you. Right? Now, if you try to search the value using this now, the cardinality will go for the unique scan, not with range scan. It is not going like a range. It is going for the unique scan. So how the other numbers having. See, you can treat like as a ration card or white card we have, right? That is a range scanning mechanism because whole family is having the one ID. Unique scan, just like as a Aadhaar ID. Okay. So this is about unique index. Simply, if you create, if you create index for the salary column now, right? It won't allow the duplicates I said, right? So if you create the index on the salary column, that need to be error. Okay. If I create index on the salary column. See, cannot create a unique index. Duplicate key is found. Duplicate key is found. Okay. So this is about the indexes in the Oracle. Okay. So what are the privileges is required? So what the prerequisites we have use indexes. Okay. So we'll recollect by tomorrow. Okay. So I will recap each and everything by tomorrow. Okay. See, no one is answering like as expected actually. I'm going to take some practical sessions. Oh, like tomorrow, I'm going to. So now we are in indexes, right? So we have the sequences and synonyms. So I need only 1 day for these two topics. Okay. So then we can practice each and everything in the SQL. Then we can plan for the PLSQL.